Very good morning, everyone. Myself, Priyadarshini, working as Assistant Professor of the Degree Department in Automobile Engineering College. And today we are going to see the topic from the subject Digital Signal Processing. The topic is Z transform and its properties. So, what is Z transform? So, it is a transformation which is used to analyze the discrete time systems. Okay. So, the definition of the Z transform, okay, how to analyze the signal. So, X of n is defined as x of z is equal to summation n tends to minus infinity to infinity x of n z to the power of minus n. And z is our complex variable. So here, the next concept of the Z transform is the region of convergence. The region of convergence of x of z is the set of all the values of z for which the x of z attains a finite value. The Z transform an ROC of different duration sequences. First sequence is called as a right-handed sequence. A right-hand sequence is one for which x of n 0 for all n less than n naught, where n naught is a positive or negative but finite. If n naught is greater than or equal to 0, the resulting sequence is a causal sequence and positive time sequence. For such a type of sequences, the ROC is the entire Z plan. X of z is equal to 0. A left-handed sequence is one for which x of n is equal to 0 for all n greater than or equal to n naught, where n naught is the positive value or negative but finite. If n naught is less than or equal to 0, the resulting sequence is an anti-causal sequence. For such a type of sequence, the ROC is entire Z plan except z is equal to infinite. So we will see a problem. So find the Z transform and the region of convergence of a causal sequence. So x of n is 1, 0, 3, minus 1, 2. This arrow indicates x of 0 is starting, that is x of 0 is 1. So here, if I am going to convert this into a Z transformation, so first we are going to write the formula x of z is equal to summation n tends to minus infinity to infinity, x of n z to the power of minus n. The next is you substitute the value. So how many values are there totally? So n tends to 0 to infinity, x of n z to the power of minus n for the causal sequence. So why it is a causal sequence? Which only we are having the right hand side values. So on expanding this, you substitute the value from 0 tends to infinity. So how many values are there totally? So totally there are 5 values. So x of 0, x of 1, x of 2, x of 3 and x of 4. So 0, starting from 0 to 4. So the values are x of 0, x of 1, x of 2, x of 3 and x of 4. By substituting all the values, x of z is equal to 1 plus 3 z to the power of minus 2 minus 1 z to the power of minus 3 and plus 2 z to the power of minus 4. And after writing this, since it is of a minus 2, we can take that in the denominator. And by substituting z is equal to 0, it will be going to the infinite. So except z is equal to 0, for all the values, it's going to get converged. The next is find the Z transform for the sequence. Okay, x of n is equal to 2, minus 1, 3, 2, 1 and 0, 2, 3, minus 1. So the center value, the arrow is indicating in the center. So we are having the right hand side as well as on the left hand side, that is causal as well as the non-causal sequence. So x of z as usual, you write the values from minus infinity to infinity. So where the values are starting from, since this is 0, the side is x of 1, 2, 3, 4, and the side is x of minus 1, minus 2, minus 3, and minus 4. So the initial value is starting from minus 4, and the final value is ending at the 4. So the n tends to minus 4 to the 4, x of n z to the power of minus n. So now you substitute the values starting from the minus 4 to the 4. So by substituting that, x of minus 4 is z to the power of 4, and x of minus 3 is z cube. X of minus 2 z to the power of 2 and x of minus 1 z to the power of 1. And then on the right hand side, you will be having negative values x of 0 z to the power of 0, x of 1 z to the power of minus 1, minus 2, minus 3 and minus 4. By substituting all the values, you will be getting the positive side as well as on the negative side. So it will converge for all the values except z is equal to infinite and z is equal to 0 since we are having both the side sequences. So summary of the region of convergence as well as the discrete time sequence. When comparing to finite, that is right hand side, is the causal sequence entire Z10 except Z is equal to 0. And finite left side anti-causal except Z is equal to infinite. And two-sided Z is equal to 0 and Z is equal to infinite. So now we are moving to the properties of the Z transform. The first property is the linearity property. So the linearity property is nothing but when we are having two or more individual discrete signals or multiplied by the constants, their respective Z transform will also be multiplied by the same constants. A1 x1 of n plus a2 x2 of n is equal to a1 x1 of z plus a2 x2 of z. So proof what we are going to confirm is x of z is equal to summation n tends to minus infinite to infinite x of n z to the power of minus n. So the values are moving from minus infinity to infinity. So now we are substituting that x of n values. The a of n is going to be, that is a1 is going to be the constant, and I am taking that out. So x1 of n into z to the power of minus n is nothing but x1 of z, and x2 of n to the power of z to the power of minus n is x2 of z. So the property is getting proved. The next property is going to be the time shifting property. The time shifting property depicts how the change in the time domain in the discrete time signal will affect the z domain, which can be written as x of n minus n naught is tends to x of z to the power of minus n. That is, n minus n naught will be coming as z to the power of minus n. So if I'm having x to the power of x of n minus 1, this can be written as z inverse x of z. So here the proof for that is I am taking a function of y of t is equal to xt minus k, and I am substituting that value, and finally I am getting the answer p tends to minus infinite to infinite xt minus k z to the power of minus p. And after that, let's what is p minus k? I am taking as another variable s is equal to p minus k, and here I am changing the values. K tends to minus infinity infinity. This is my old function. And finally, I am getting that z minus k x of z. So it is a time shifting property. The time has been shifted. And the next property is going to be the time scaling property. Time scaling, how far it is scaled, the values. A power n x of n is equal to x of a inverse z. So here they are proving with this concept, and here also they are taking an example of y of p is equal to a power p x of p. So what is y of p? That is summation p tends to minus infinite to infinite y of p z to the power of minus p, and you substitute all the values, and after that x of a inverse z. Hence it is proved. Okay, next is successive differentiation. So the differentiation property of the z transform. So what is successive differentiation? So property shows that z transform will take place when we differentiate discrete signal and time domain with respect to the time. dx of n by dn 1 minus z inverse x of z. So here we are considering the LHS of the equation, and the final answer is 1 minus z inverse x of z. So here the differentiation, that is dx of n by n, is 1 minus z inverse x of z. So this is our final answer for this successive differentiation. And the last one is going to be the convolution. Convolution is nothing but the two signals will be convoluted by using the Z transform property. This depicts that change in the Z domain of the system when a convolution takes place in the discrete signal form, which can be written as x1 of n cross x1 of z into x2 of z. And what is x of z? We know that summation tends to minus infinite to infinite x of n z to the power of minus n. And similarly, and we are going to substitute that property x1 of k and x2 of n minus k, and after multiplying, the final answer is going to be this. So here x of z can be proved as tends to minus infinity to infinity x1 of k z to the power of minus k, and L tends to minus infinite to infinite x2 of L and z inverse. And after that, these two answers they are combined, and final answer is x1 of z into x2 of z. So here in this video we crossed we saw what are the properties of the Z transform, what is the Z transform, and what are the sequences of the Z transform. Okay, thank you.